Okay, with question 6, it shapes of molecules. So sodium reacts with ammonia to form the compound NaNH2 that contains the NH2 minus ion. Draw the shape of the NH2 minus ion. Include any lone pairs of electrons that influence the shape. So we've got to predict the bond angle, justify your prediction, draw the shape. Okay, let's go. So nitrogen is in group 5, so it has 5 electrons in its outer shell. Now, hydrogen has 1 electron in its outer shell, which it brings, and there are 2 of them. And there's a minus charge here, which means I need to add 1 to that. That gives me 8 electrons. Now, the electrons are always in pairs, so I divide by 2, which equals 4 pairs. So let's draw it first. So with 4 pairs, the parent shape is going to be tetrahedral. So let me put nitrogen in the middle. So there's nitrogen. Let's draw my tetrahedral shape. Only with my 4 pairs that I've got here of them. Now I've only got 2 hydrogens on there. So 2 of them are going to be bonding pairs. And if I've got 4 pairs, that means that 2 of them are going to be lone pairs. So I need to rub 2 of my pairs out, which I'm going to rub those out and replace them with lone pairs. 1 there, 1 there. Put the hydrogens on the end, which gives me that. And of course, the bond angle on tetrahedral is 109.5 minus 2 lots of 2.5. Which equals a bond angle of 104.5 degrees. Okay, the justification here, well, there are 2 bonding pairs and 2 lone pairs of electrons that repel around the central atom. Okay, next point. Lone pairs repel more than bonding pairs. And of course, that's because they're closer to the central atom, so they repel more. So where are the marks for this? Well, there's 1 mark for the correctly drawn shape. Of course, that's non-linear. There's 1 mark for the correct bond angle. There's 1 for counting the bonding pairs and the lone pairs. And there's 1 for stating that the lone pairs repel more than the bonding pairs. So let's go on to part B. So SiF4, so silicon tetrafluoride, is a tetrahedral molecule. Deduce the type of intermolecular force. So intermolecular means that it's going to be van der Waals, permanent dipole to dipole, or hydrogen bonding. Explain how this type of force arises and why no other type of intermolecular force exists. So let's have a little look at the shape first. So silicon. Now we know that fluorine is the most electronegative element, so it's going to be D minus is all around here like this, and the silicon in the middle is going to be D plus. And of course, the thing that we need to look at here is, does it have a D plus end and a D minus end? And the answer is no. And if the answer is no to that, then we say that the molecule is symmetrical. So we'll jot that down here, that the molecule is symmetrical. Therefore, the dipoles cancel out. So what does that mean then? Well, if there's no permanent dipoles, and it can't be hydrogen bonding because I've got haven't got oxygen, nitrogen, or fluorine, or hydrogen, or lone pairs, then it must be van der Waals forces of attraction. Now, when you're doing these answers, you can't abbreviate the first time you write it. You can do it, if you do that, you can abbreviate it from there on in, okay? So the explanation then, so it's the van der Waals explanation, so it's due to an uneven distribution of electrons. Therefore, you get a temporary dipole. Which induces a dipole. In a neighbouring molecule. So, van der Waals explanation, and the reason there's no other forces because the molecule is symmetrical and the dipoles therefore cancel out.